VXLAN lab. Part 1 is Intra-VLAN routing. Hello everyone, this is my new BGP EVPN VXLAN lab. Welcome to my channel. Don't forget to subscribe. This is a detailed lab in which the BGP EVPN VXLAN is implemented in the Cisco VNXOS L3 switches. I explain the concept involved in BGP EVPN VXLAN and will show various outputs and packet captures and explain the data plane operations, why VXLAN is introduced, and what problem it solves comes under theory. You are recommended to cover the why VXLAN parts to phone standard books or otherwise. We will construct the exact below topology, and you are strongly recommended to establish the connections and names interfaces exactly in the same way as it is done in the topology. So let all discussion during the labs aligns well. So we'll configure the same IP address is shown in the topology. Don't be deviate. The topology is layered, spine layer, leaf layer, and end host layer, as you can see in the diagram. At a minimum, I must deploy the R1, L1, L4, host 1, 2, 5, 6 nodes. I will not use the other nodes in this lab. Leave 2 and leave 3, host 3 and host 4, but you are free to extend the topology at your wish to experiment more. All spine and leaf nodes are the same NSOS V3, L3 switches. So total 3 NXOX virtual nodes I will need to deploy. Spine 1 is called R1, leaf 1 and leaf 4, and hosts could be any nodes that supports minimum network functionality like ping, ARP, etc. I can use the VPC's host computing in the GNS3 and no need to install anything. So in my lab, I prefer to use the Cisco ASA firewall images. The host image type don't matter. So to put in a few words, our goal is to make a ping 192.168.10.11 success from the host 1 node, will ping host 6 from host 1, and this covers the intra-VLAN routing. So we want to ping from a machine in VLAN 10 to another machine in VLAN 10, but both VLAN 10s are separated by the VXLAN network and fabric. All the links between the spine 1 and the leaf 1, 4 are layer 3 links. We need to deploy unicast configuration and multicast configurations to start with. The objective of the unicast configuration is to simply set up IP reachability among all spine and leaf nodes in the network. We need to configure IP address on all interfaces connecting spines and leaves. We need to configure loopback address 0 on all nodes with the /32 host loopback address. And we deploy a routing protocol OSPF, ISIS, or between the spine and the leaves so that every node is reachable to every other node. Log on to spine 1. Well, first enable is my feature OSPF. Then router OSPF called underlay route ID 110.1.0.1. That's it. And we'll interface loopback 0, no shut, IP address 10.1.0.1/32, IP router OSPF underlay area 0, IP OSPF network, make it point. Next, we want to configure is my Ethernet 1.1. 1.1 with description is this interface to leave 1 Ethernet 1.1. No shut, no switch ports, then our IP address 10.1.1.2/30. Okay, IP router OSPF underlay area 0. IP OSPF network point to point. MTU we use 9000. Okay. Next interface Ethernet 1/2. Description is 2 leave 2 Ethernet 1.1. Exactly in the diagram. Okay. No switch port. We'll configure my IP address 10.1.2.1.2/30 IP router OSPF underlay area 0 IP OSPF network point to point. MTU 9000. No shut. Show run interface E12. Show run interface E12. Here you go. But this interface is E14, so all we do is go straight to E14 interface. E14 description is 2 leave 4 Ethernet 1.1. No switch ports. IP address 10.1.4.2/30. IP router OSPF underlay area 0. IP OSPF network point to point. MTU 9000. No shut. Show run interface 1.4. Go log into leave 1. The leave 1 will be configuring the feature OSPF router OSPF underlay. Okay, router ID 10.0.0.0.1 is the loopback. Interface loopback 0, IP address 10.0.0.0.1/32. IP route OSPF underlay area 0. IP OSPF network point to point. Interface E11. My IP description is 2 spine 1 Ethernet 101. So no shut, no switch port. IP address 10.1.1.1/30. IP router OSPF underlay area 0. IP OSPF network point to point. MTU 9000. And we can do a ping test, ping.1.0.0.2. Yes, interface EU. No more interface, leave 2 now. Sorry, this is leave 4. Let me change the name. 4. Okay, good. Same drawer, OSPF, enable, router OSPF underlay, router ID 10.0.4, interface loopback 0, no shut, IP address 10.0.0.4/32, IP router OSPF underlay area 0, IP OSPF network point to point. Interface is Ethernet E11. IP description 2 spine 1 Ethernet 1.4. No shut, no switch port, just 10.1.4.1/30. IP router OSPF on the lay area 0, IPOSF network point, MTU, don't forget 9000, okay, ping 10.1.1, going to the interface to change the IP ping 10.1.4.2, yes, go to spine, show as OSPF neighbor, yes, show IP OSPF, show IP route OSPF, leave 1, leave 2, yes, I have a route. The next part is to configure the multicast. The objective of multicast configuration is to efficiently distribute a BOM, unknown broadcast, unicast, or multicast traffic called BOM traffic, BUM. We're going to enable ping sparse modes on all interfaces connecting spines and leaves. We'll configure spine and rendezvous points, the RP. Make leaves, leave 1 and leave 4, and the last hop router for multicast group 239.1.1 and 239.2.2.2. Let us log into my spine 1. First, we'll enable a new feature called feature ping. Okay. IP ping RP address we need to specifically saying what is RP 10.100.100.100. Then IP ping anycast RP 10.100.100.100. And it is my 10.1.0.1. Show IP interface brief. It is my loopback 0. Okay. Interface loopback 0. No shut. It's down. Okay, up. So after that, interface loopback 0. IP ping, we enable sparse mode. Interface loopback 1. Okay, I'm creating a loopback 1. Okay, ping sparse mode. Okay, description ending cast. Description is ending cast RP. So this is my ending cast RP address. Okay, IP address. What is IP address? 10.100.100.100/32. No shut. Similarly, I have to advertise it in my OSPF. Similarly, interface E11. Here E11. Okay. IP ping sparse mode. Interface E1 full. IP ping sparse mode. Alright. Next for leave 1, we're going to configure feature ping, enable feature ping. IP ping RP address unknown in the leave, we only want to specify the RP 10.100, 100, 100, 100. Interface. Okay. Loopback 0, IP ping sparse mode. Interface. What's my interface? 11. Okay. IP ping sparse mode. Alright. Leave 4. We'll do the same feature ping. Let's say show IP interface brief. Yes, I loopback up. Feature ping IP ping RP address 10.100.100.100. Interface loopback 0 IP ping sparse mode. What is interface? E11. E11 IP ping sparse mode. Interface E11 IP ping sparse mode. So at this time, go to IP spine 1, show IP ping neighbor. Okay, I have 2 neighbor, ping neighbor. How do we test? Okay, go to leave 1, ping, okay, ping multicast
239.1.1.1. Interface is E11. Okay, I cannot ping for now. Let's try it one more time. No ping for the group. Did I miss the interface? IP ping RP address 10.100, 100, 100. One more time. I'm pretty sure I have my ping, and we'll skip the pinging task. Next, we'll straight go to my VXLAN config. Now we need to do basic VXLAN configuration. VXLAN configuration needs to be done only on leaf switches. This is my leaf 1 and 4. After this VXLAN configuration, any host in the same VLAN must be able to ping each other. So log on to leaf 1. Okay, in leaf 1, we should do is feature interface VLAN feature MV overlay and feature VN segment VLAN base for the mapping. When you enable new interface MVE1 no shut, source is my loopback 0, member say VNI 5010 MCAST member VNI 5010 say MCAST group 239.1.1 exits member VNI 5020 MCAST group 239.2.2.2 will enable to VLAN 10. We're going to choose VLAN segment, that's my 5010, VLAN 20, VLAN segment, say 5020. Show run as VLAN, show run VLAN. Here you go. I have VLAN to VNI mapping. Now we should take care of is my interface to host 1 and host 2. They are in Ethernet 1.3 switch mode access, switch access VLAN 10, interface E14, switch mode access, switch access VLAN 20, switch mode access, switch mode, switch port, switch mode, mode access, switch mode access, switch mode access. Okay, show run interface E13, yes, E13, E14. So run interface MVE1. Here you go, have interface, have VLAN, that's perfect. So let's log on to leaf 4. Going about feature, interface, VLAN, feature, MV overlay. Feature is VN segment VLAN based interface, MVE1 no shut, source interface my loopback 0, member BNI 5010, same thing, 239.1.1, member BNI 5020, MCAST 239.1.2.2.2, VLAN 10, VM segment 5010, VLAN 20, VN segment 5020 interface. We're doing this for my host 65. Interface Ethernet 1.3. Okay, Internet E13. Switch mode access. Switch mode access. Switch access VLAN 10. interface E13, E14, switch mode access, switch access VLAN 20. So okay, show run interface MVE1, yes. Show VLAN, show run VLAN, yes. Show run interface E13, E14. Okay, VLAN assigned, MV interface is there. Now we're going to log on to my host servers and do some pinging. Okay. Let me log on host 1, host 2. So from host 1, we're going to ping host 2. No, ping is not there. After a while, I'm pinging from host 1 to host 6. Alright, it's pinging. Now host 2 ping host 5. Yes. Host 6 ping host 1. Yes. Host 5 ping 10.10. Oh, no. Host 5 is 20.10. Yeah. Yeah, okay. Everything's pinging. All ping are successful. It means that our VXLAN deployment is successful. So far, our VXLAN deployment supports only intra-VLAN routing communication within the same VLAN. So I can realize that VLANs have been extended. For example, same VLAN, say VLAN 10 is now present behind multiple leaves, like leaf 1 and leaf 4. Same is true for VLAN 20. Also, the bomb traffic is handled through the multicast. As you could see in this diagram, um, this bomb traffic handled through the multicast. So as opposed to ingress replication, which is not an efficient way of handling bomb traffic. If there are 1,000 leaves, so also called VTAPs, we call virtual tunnel endpoints in the data center, it can be 1,000 VLAN 10 segments, one sitting behind each leaf. All hosts in those VLAN segments can seamlessly communicate as if they are present in the same traditional VLAN segments tied to the same VL2 VNI. We'll understand step by step how the intra-VLAN communication is achieved in VXLAN based network. Let's say the host 1 ping host 6. Okay. The host 1 ping 192.168.10.11 in this way. Okay. Let's see what are those operations involved in making the ping work. So let's stick with L2 switching and L3 routing fundamentals to understand the data panel operations. So let's see the status of leaves to VTAPs, leaf 1 and leaf 4 before user ping. So we have a MAC address tables on leaves. Let's multicast routes on the leaf and spines. We're going to show IPM route, ARP table on the host. L3 unicast routing table is not involved since we are doing intra VLAN communication. Okay, go to leaf 1. We want to show MAC address table. Simple as that. Okay, what is my host 1's MAC address? It is 333. Okay, host 2 it is 16F7. You can easily identify them as on the local ports. And after ping, I can find a remote host. Then let's show IPM route. Okay, show IPM route. We use two groups. Why? We have 239.1.1.1 and 239.2.2.2. Right, show run interface MVE1. Here explains you why we're using two groups for VNI, VLAN 10, and VLAN 20. Well, note that outgoing interface of these rules is like, MVE. This SG routes are responsible to process the ingress multicast. The MVE, which decapsulates the multicast packets. Source interface in this case is 10.0.0.1 is my loopback 0 interface is 10.0.0.1. Using this IP address as a source, leave one sends a dummy registered packet to RP to complete the first hop router registration process proactively. So without app data involved, this can be done, and this does this for both group. Since so the more SG routes are created on the leaf, 10.0.0.1 slash 23, and for the group is 239.1.1.1 slash 32, and a group SG 10.0.0.1 and it's 239.2.2.2. These routes enable routing the locally generated outbound multicast traffic from the first hop router to the RP. Well, note that the OFI of these routes is an interface towards RP. As the parts of a registration process, the S is my loopback interface 10.0.0.1. G is the two group 239.1.1.1 or 239.2.2.2 routes are created on the spine 1 also. So the SG routes enable processing of ingress MCAS route. SG routes enable routing of egress MCAS traffic. To show you that, go to spine, show IPM route. Here you go. Very similarly, we'll go to leaf 4 here. In leaf 4, show IPM route. There you go. Leaf 4 also have a 4 MCAS routes in its multicast routing forwarding table. So the two are star G, and two for SG, source and group. Same explanation I have told you above, and show run interface MVE1 here is the group we're using. The 10.0.0.4 is my leaf 4 loopback 0 interface. Now go to spine 1. I can see spine 1 receives the gping join group 239.0.0.0 and 239.2.2 from leaf 1 and leaf 2 on interface 1, 1 and 1, 4. And a group 239.2.2.2 with OFI interface E/1 and E/4. As a part of the ping registration process, the spine also create 4 SGs. There's 2, here is the 2 SG. So use these SG routes. The spine receives MCAR's traffic, multicast traffic, and forward them to respective outgoing interface. You get what I say. Now let's take an example. Host 1 pinging host 6, 192.168.10.11. We are pinging this on host 1. So host 1 first checks its local ARP cache to find the MAC address for 192.168.10.11, but it doesn't find it since it is a first ping. Then host 1 launches ARP broadcast request packet is showing to the VTAP leaf 1. Since the destination is the same subnet as the source, um, you know, then these packets will be received by the leaf 1 on port Ethernet 1/3, which is in VLAN 10 access mode. Here you go, access mode VLAN 10. Then the packet will get tagged with the A02.Q header with VLAN 10. Then this packet is handled by the data link layer, we call L2 layer. Then leaf 1 does MAC address learning. So show MAC address table. Here you go, your table. Since the packet is an Ethernet broadcast, the VTAP leaf 1 data link layer floods the packets on all the ports which are in VLAN 10. Okay, this is what happened. Okay, so leaf 1 look up the MAC address table. What is VLAN 10? For the MAC address is broadcasting the MAC address FFFFF. Then the result is send packet out interface to MVE1, okay, which is a multicast IP. This sends broadcasting frame to this layer 2 broadcasting to frame to this address. Okay. Then I'm gonna show you a table. Show MVE internal platform interface MVE1 detail. I have never saw this table before. The table here, first entry says any packets that arrive on VLAN 10. Take a look at this. Any packet arrive VLAN 10 on leaf 1 will be sent out interface MVE1 using VNID 5010. Any packet sent out interface MVE1 shall be encapsulated as VXLAN packet. So the destination IP address of outer IP header of the packet is not known from this table. So it has to be provided as additional parameter by the entity that is trying to use the MVE1 as an egress interface. So we configured show run interface MVE1. We configured MV leaf 1 responsible for building the table. The same table exists on leaf 4 also. Sent to this interface, this IP. Show on use the same table MVE internal platform interface MVE1 detail. There you go, same table. So as a result of MAC table lookup, the leaf one prepare the second packet with the fields, additional header, right? Leaf one looks up the table, which has VLAN NVI mapping. Also, then knows for the VLAN, VNI to be used is what's called like 5010. 5010. Great. So the destination IP address will be 239.1.1.1, and the source address to be used in an address of the interface, which is taken as a source of NVE1 through the configuration, is my interface NVE1 is my loopback 0. This interface IP. Okay, now we have a destination, we have source IPs, and we know what to put in for the UDP header. That's 4790A 89 as a destination port, 4790A for VXLAN, and the VXLAN header VNID is 5010, right? And then we'll encapsulate what? The ARP message, okay, in the packet. So since the packet 2, second packet is a multicast packet, the leave one will forward it to my spine. Okay, using the matching MCAS routes, right? We have show you one more time, show IPM routes, showing using this M routes. We can verify using show IPM routes on leaf one using this command. And leaf one is acting as a multicast first hop router. The destination MAC is going to be show MAC address table, which is my host 6 MAC address, which is EC1A. Okay, EC1A here, this one. So this MAC address is obviously MCAS MAC address, which is derived from group address. So when the spine receives the multicast in packet 2, second packet, it forwards the multicast packet to leaf 4 using multicast route entry. Which route entry? Here you go. Because it will forward me, because it's Ethernet 1, it connects to leaf 1. Okay. Finally, then leaf 4 receives the second packet. The packet is multicast packet. So the packet is processed by multicast stack. So leaf 4 can process this packet only, and only if has a multicast route in multicast forwarding table. Do we have it? Yes. And it is star G multicast entry. This route was created through my configuration show interface NVE1. It created through configuration. But what leaf4 will do with this packet and how? So if you noticed in the steps, the OIF of multicast route is, here is NVE1 interface. The NVE1 interface, when used as OIF of multicast routes, is set with decap tag. So this flag, the multicast route shall push the packet to the OIF, which is the NVE1. When the OIF interface receives the multicast packet, it decapsulates the packet rather than traditional MCAS forwarding behavior. So NVE1 will decap packets, remove the almost empty header, and detects the next header followed is UDP header, which has the destination port 4789. There's a special value which implies the next following header is VXLAN header. So to process the packet next as per VXLAN module logic. So the reception of VXLAN header packets on MVE interface MVE1 only 4 will help L4 switch to learn about MVE peer, which is my 10.00.1. Show MVE peers detail. This is my MVE pair of on leaf 4. So since leaf 1 has not yet seen any kind of package from leaf 4 before, so leaf 1 do not yet know the existence of the 10.00.4 leaf 4 as MVE pair. We actually had ping it, we could actually see the pair. So MVE pair IP should be detail. Yes. So leaf 1 and leaf 4 can be a pair. Finally, the packet reach to leaf 4 and show MAC address table. We have the same table build up. The MAC address learning is performed, and the following entry is inserted into the MAC address table of leaf 4. Okay. Then the table builds up and the packet reach to host 6. Host 6 are untagged are broadcast packet in packet 1 and host are not even aware of the packet has traversed to the spine or contain any traces that the packet has traveled via whole VXLAN network. The host 6 views the host 1 as if the host 1 is present in the local VLAN 10. So this all packet journey of our broadcast packets pinging from host 1 to host 6 through the VXLAN fabric. The last part we want to discuss is the MV interface. So run interface MVE1. Having studied how understand the basic of VXLAN data panel operation, so we can discuss the MVE interface. The MVE interface is used to decapsulate Ethernet packets with VXLAN header as well as decapsulate packets arrived from VXLAN fabric on a VTAP. The MVE interface encapsulation algorithm is a function of the two parameters, the remote VTAP endpoint IP and VNID. So that's why we only enabled MVE on the leaves. We only need to encapsulate the VXLAN packets on the leaf layer. No need for spine. Okay. Here is my whole video on VXLAN 101 Intra-VLAN communication. We demonstrated how host presence across the VXLAN fabric in the same VLAN and communicates where multicast takes the responsibility for distributing the bomb traffic efficiently across interested V taps and the routing of the packets between the host of the same VLAN across the VXLAN fabric involves only MAC address table, MAC address learning, forwarding, host despite being separated by the layer 3 VXLAN network. Logically, view each other as if present in the same VLAN or network. But how hosts in different VLAN can communicate with each other? This we'll cover in the next video in Inter-VLAN routing lab. Stay tuned, guys. See you next time.
Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below. Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below.